And we are live, second stream of the day. Let me share the link. So we're wrapping up the analysis of the length spikes, and we're going to be doing some filtering of the HBS data. Okay, let me share it here, and here is where we stopped in the last stream. Basically, I just exposed the data that has either 102 or 103 or 104 characters in length, and we saved that data in here. And so now I'm curious whether we have a ton of duplicates here or not. I'm going to rename this to something like 102 through 104, because the expectation is, okay, just ignore this, that if we set, instead of 104, if we set something like 106 to 108 here, we should have much less data. 108. Let's now kick this one off. I'm going to stop the run and kick it off again. And let's see what we get here. Hope you guys are doing well. Okay. Still a bit under jet lag from the travel. I'm not sleeping properly, but in a couple of days it's gonna be perfect. Okay. Running with a different range filter, and let's see what we end up in the new analyze lines txt file. I'm expecting much less data compared to the previous range. Let's just verify that's indeed the case. Okay, let me open up the file. And let's see, so we have 589 lines here. In the previous one, we had 633. Okay, that looks like a spike. But let's see, let's quickly do one more thing. Let's just change from 108, let's just go to like 100 to 102 or something like that, like, or 99 through 101. Let me just see whether that makes sense. 102, 104, 99, 101. And let's kick it off again. I'm gonna rename this one to 106, 108. Let's just make sure that this new file now will have roughly the same amount of data as this one here, and then we see a spike here. And then we can analyze, understand why this file has those, has much more data. I already see some duplicates here, exact duplicates. That might explain it here as well. I think that's the explanation. But let's make sure that's the case. A ton of duplicates that I can see already with my bare eyes. We don't even have to do fuzzy, we just need to do exact deduplication here and see what we get. Okay, this is weird. I'm not getting what I'm expecting. So what I'm expecting is, I'm expecting to see this spike. So if we zoom in here, or on this particular spike, I'm expecting to get less than 600,000. Here, that's indeed the case, but here, why am I not 101 through 99? Let's go 98 to 100. Maybe I'm off by a bit. Maybe we need to put 100 to 98. Well, let's maybe even go 97 to 99. Let's kick off this one. What is the cause of this spike? Yo, hey man, Saujania. Saujania, am I pronouncing your name correctly? Thanks, man. Glad to be back. And I'm not gonna try until the end of the year. You'll be seeing me here every single day. I'm planning on pushing this project really hard. Okay. Let's see what's the result. Huh. Okay, let me open up the file. Why is this 190 now? This doesn't make any sense. Hi, Rankara. This doesn't make any sense whatsoever. If we plot this, there seems to be some spikes here. Could this only be no worries, glad you like it. Okay, let me just open up this loop. Zoom in around here. Okay, instead what I'm gonna do now is from 100 to 106, let's create 6 separate files. So 99 here. Let's just do something like okay, let's create a dictionary. And from 100 to 106, I'm going to length 1 and do, maybe we can do default dictionary here, default dictionary, and then we want to append, we want to have a list, right? We want to have a list. So lines of this length and we just say extend with this line. Is this correct? So we'll be extending and then we return that back here. And once we have that, we can't just extend like this. Instead, we'll have to also have a default dictionary of a list there, and then we'll have to do something like for key value like that, and then exactly this should now work. And finally, let's go through the items. Let me see, let me think for a second. So for key value in this, we open up and we make this an F string, and we can do something like this here, convert this into a string, and then set fillet to 3, and then we can save this now. So now we go through the lines in the value. It's kind of dirty and hacky, but it works, I think. So let's see. I think this will now work. Let's rerun. Okay, let's go here. Temporary lines. Okay, as you can see, from 100 to 105, and then we go through those, and then we just extend, and that's it. I think we're good. We're good there, and ultimately, I just want to test this works. We'll end up with 6 different files, and we can see the lengths of those files. If there is no spike, then I guess it's just a matter of how the histogram is computed. Might be just some glitch where they group 2 bins into a single one, something along those lines. In that case, we are done. We can close the task and just yeah, just wrap up the task and continue working on the next tasks. Here we are. So value. Okay, let's just save that. And let's see what we end up with. Here we are. As you can see here, let me just ignore these files. This was like 99, 97, 99. And then just make sure they're grouped here. Ignore. Just renaming the file names so that they are grouped up there, so I can analyze them quickly. Something along those lines. And now let's see whether there is any weird spike here. Okay, ignore. So 222 here. A bit less here. That's expected. A bit less here as well. A bit less here to 210. 208. This is all expected. 203. This is all expected. And 199. So all of this makes sense. So that means It was just some glitch in the actual histogram computation, not in the data itself. Okay. Thinking for a second here. So if that glitch does not exist, then why are we seeing the spike in the histogram? Where do we see this spike? And why is the spike just so small? Why is it not like 2x? Or maybe it is. Let's see quickly. Pick the zoom here. $400 something, and then a bit more here. No, this is definitely some artifact of histogram computation. It seemed too regular. Okay, we can ignore this. I'm gonna close that task. Let me just close up all of this. Okay. That was it. So now, number of tokens in SPM 200 for the 1050 characters in HBS. How can we do this analysis? We probably don't care. Let me think for a second. We already have this information, I think. Basically, the line length factors. Okay, this one in Stopes under filter configs. Exactly here, and then Serbian. It's roughly the same coefficient as with English. But does this use the tokenized sentences or just raw sentences? I think it's the latter. Let me see. How are these computed? So we have where is the script that computes this? Okay, length factors. Here it is. So what we do is we open the files. And then we just see what's the length when we read them. But that's not what I care about, right? I need to see what's the tokenized. What's the difference when you tokenize them? Let's do that next up. Let's quickly modify this function here so that we also get the length after tokenization. So how can we do that? Recall where am I using the tokenizer? Okay, I'm using the tokenizer in the data preparation scripts. So prepare data and then build vocab, binarize. This one should be calling the tokenizer somewhere. Yes. SPM model path, binarizer. Process the file chunk. Line processor. Okay, let's see what's the line processor. So prepare data. Again, go to binarize. Line processor is here. Let's find that one. And let's see how it. So it loads the SPM tokenizer. Can I just reuse some of these? Let me think for a second. Okay, I think we can just load it directly and then tokenize. If it's not none, then we call it and encode as pieces. Where is this function called? Nowhere, but we pass in this function to vocabulary dataset binarizer as the second argument. Okay. That's it. We load and then we create the. Yeah, we just load from the path. Okay, let's do that. Let's grab this. Let me reopen the FairSec. Actually, line length. Line vector. Where was this? Let me find the filtering code. Here it is. Filtering. Compute length vectors. Okay. We can quickly modify this, doing something like this. And we can remove the self. Let's just hard code the SPM model path. So SPM, more likely here we'll find the SPM path. Whoops. Okay. Here is the model. Copy the path. Go to Stokes. Go here. Here's the model. And then we need to import the SPM. Like this. Let's import this. And then SPM dot sentence piece processor, and we load. And now we can finally use it. Down below, to compare how much more verbose is HBS compared to English when it comes to tokenization. Okay, to answer that question, let me just see how we call the SPM. So we call it here, and then we just do encode as pieces, and then we pass in the line. Okay, so that's all we need. Now we need to open the file called read. Let's make this data and then pass in data here. And then additionally, for line in data, split on here. If line exists, then get that. Okay, then we get what? We get the length in tokens of a line. We want to find the average. We want to find the average. So we'll just be appending here. Until at the very end, we store a tuple here, length of the data, and then maybe you can do something like numpy as array, and we get the mean. And we can just import numpy here. So that gives us, for Flores 202, the average number of tokens per sentence. And then we can just put a breakpoint here because this is just a temporary piece of data that I need. Okay. I forgot to remove this. Let's rerun. Let's see whether this works. 80, 79, okay. Run. Do I plan on reviewing new LLMs like JICE 313B chat? When you say reviewing, I'm not sure what you mean. I did cover the paper in one of these streams. That's the Arabic LLM, right? Okay, let's see. What's up with English here? Where is English? Let's grab English data. So English is 28.99. Okay, let's see. For something like Serbian Latin. Aha, something like Serbian Latin does not even exist. That's weird. Should we get... Aha, because we're dealing with Flores. So we probably only support Serbian Cyrillic. Yes. Okay, so here is Serbian Cyrillic has 36 tokens per line. I didn't try the model because it's currently not relevant to machine translation necessarily. So yeah. You can always open up an issue on the community page on Hugging Face. Let me see for Bosnian. 34, let me see Croatian. 34 as well. So Serbian turns out to be the worst. Let me just grab all of these. I'm gonna create a temporary variable where I'm gonna iterate through the factors. Okay, and then just fetch the second value. And that leaves us with this, and then let's find, let me convert it into a numpy array. And then let's find the min and max. Min max 73. Let's see, so that's the mine. Okay, let me sort. Let me just sort it. Oops. Okay, I messed it up. Okay, here we see what's going on with different languages. So definitely Serbian is among better ones compared to how bad it can get. Serbian is not that bad. English is what? English is 28.99. So English is here. Serbian is like somewhere here, 36. Bosnian and Croatian are around 34, so they are even a bit better. But all of them are here up close to the top. Okay, that means the tokenizer is not that bad for HBS languages. The SPM 200 tokenizer is not that bad. Let me go up here. So the question now is, if we have a sentence that has 1050 characters, what's that gonna translate to when it comes to tokens? Let's grab a Serbian sentence that has that many words. Let's just randomly grab something and see what we end up with. So I'm going to go back to VerSec. I'm gonna open up some of the Serbian data. So here, and maybe open up one of these. Let me just find some normal sentence in Serbian and make sure it's around 1050, and let's see what we get when we tokenize it. Okay, let's just grab this. The length of this one is around 100 characters. Let's go back to the length vector computation in Stopes. I'm gonna call this a test sentence. Okay. Let's grab this sentence. And let me see what we get here. Okay. So we now, I just want to see the print. Okay. length of the sentence and length, we tokenize it. How many tokens do we get? Because we are limited to, let's say, 512 tokens. That's the number, that's the context length that NLLB project used. We can of course experiment, but let's just see how this is gonna look like. Okay, this is 324. So that means we'll never we'll hardly approach 512 context length throughout the training. Even if, yeah, if we have only 1050 characters, even if we had like some weird edge case where every token only represents 2 characters, even in that case, we still won't be able to go to the full context length of 512. Does that mean we need to maybe reconsider the upper threshold, maybe, which is currently set to 1050? Okay. So we saw this is roughly 300. Obviously, that's gonna vary a lot, but I doubt it's ever gonna hit 512. Let's go to the filtering stage. I'm gonna open up Stopes. Bollywood Musty had a question about, we're building an AI agent to automate DevOps process using LangChain agent and Llama 70B model. What do you suggest we can do to improve it? It's a fairly open-ended question, and it's not related to what I'm doing here, so it will be like a big context switching for me to answer that question. But feel free to ask a question in the Discord server. Somebody will reply, maybe even I, after the stream. Okay, filter.py. Let me see. What do we want to do here? Example, find the filter config example. So we want to modify this one. And then kick off the filtering run. I think what makes sense for the settings. I'm gonna put the Notion page on my other screen, so I can just do quick comparison. So what do we want to do here? I see we have train line and train BT here. Maybe those are adding the labels that I was looking for. We basically want to add a special token to our data, telling us from which data source is the data coming from. Is it the primary data set, is it the mined or the back translated? Maybe this answers my question. I'm gonna check that in the code very soon. We need to add toxicity filtering as well, fuzzy. None of that is currently here. And LID as well. Ideally, we'd have some LID filtering. Let me think. Length filter default. Train primary LID filter. Where does one get these settings from? Just recall that. Example. I think this is directly in the filter script. So if we open up the filter script here and put it here, filter config, group filter config. Okay, here it is. Keeping the default settings. We'd end up doing the duplication and length filtering, but not LID and not toxicity. Cluster local. Well, that is, I think, fine. We don't have to touch that. Directions, YAML, unfiltered corpora. Okay, let's see. How that's computed. Populate data config. What's the output of this file, of this script? Okay, train primary. This is the output. And we need to change this. Okay. Let's go back to PearSec. I need to merge all of these together. So I'm gonna create a temporary script here. This is temporary LSH or fuzzy. Let me create a temporary file this temporary script will just merge the data. So merge HBS data, and then pass in the yes, data path is this, and then we have Serbian, and then we have Croatian. Okay, that's it. Let's merge all of them together into a single output directory. So we'll have the output directory that we're gonna call the Opus HBS, or actually just HBS data, because it's not only Opus, we also have Makoku. So let's just make a directory here. Let's import this. Import the OS package. And then we need to just move stuff from let's see what Copilot recommends me. Not really. That's not what I want to do. And these will not be files, these will be data sets. So yes, data sets. Creation data sets. So we go through create a path, and then we just need to move this one using sh-util. Will this work? And if I just do the same for 2 other languages, will it be smart enough? Or I have to do any additional logic? Let me see. Put a breakpoint there and kick this off. Okay, here is the HBS data. Okay, we move. Okay, this looks legit. I'm gonna stop this now. And let's do the same thing for two other languages. And now the same thing for Croatian. Okay, will this work? The first one will work, but then so we can delete this. or we can just leave it for now. So now if we go and do this, we have Serbian, excellent. Will this now be smart enough to just copy paste the direction, the language direction to HBS? So we have excellent, and you can see here we have English Latin to Bosnian and English Latin to Bosnian Latin. Bosnian Cyrillic and Bosnian Latin. We just move. Okay, this failed because this already exists. Yeah, I expected it will be smart enough to just paste the underlying directories, but it's not. Okay, in that case, we can say try and move it. If that does not succeed, then we pick out okay, then we do the following. So we try this. If it doesn't work, then out there is gonna be we list the directories underneath this path. And then we create the paths. And then we move those. But not to the out directory, but instead out directory followed by Serbian dataset. Something like this. And this should now work, I think. Let's just double check this works. Okay, Serbian, we try, it's gonna fail. Then we grab the underlying directories, and then we move these paths to here. Did that work? I think it should have worked, and it did. Here is Serbian Cyrillic. Okay, perfect. Perfect. We are done there. And finally, we are left with Croatian. Same logic here. Try and do this. If it doesn't work, grab the child directories and then move those to here. Okay, makes sense. I think this should work, guys. Just kick it off. And that's it. We have everything we need here. Creation is empty as well here. So we can now just delete. And here is our data. This is the HBS data. Now I'm gonna copy this path, go back to Stopes, and now we can call them these 3 scripts to prepare the configs. Let me quickly turn on the light here. I'll otherwise become blind in like 30 minutes. Just a sec. Okay. Let's go. Let's see what we need to do here. So train primary. This is going to list now all of the paths that we have in our data set. For the time being, I think we need to ignore Latin for Serbian and Cyrillic for Bosnian. Let me see what that leaves us with. How much data do we have? How much Serbian data do we have in Latin? How much in Cyrillic? Just to understand what I'll be ditching by ignoring that subset of data. Let me think for a second. So here is Versec. Let's find all Serbian Cyrillic here. And let's see how many lines will we have. Okay, copy path here, go to analyze data. What we care about is not line length, but instead we care about number of sentences. And analyze. Like this. And let's not kick this off. Number of sentences. Let me just revert back some of these changes that we made that we don't need anymore. Okay. Now we care about number of sentences, as I said previously. Put a breakpoint here. Kick off this run and see whether it works. Yeah, I saw some bad codes in the output here. That's something we have to double check. Why did I see Croatian only with HR? Okay, looks good. Okay, here's one that's not good. CC aligned. That's the one that caught my eye. It looks like that's the only one. Every other one has the right language code plus the script, except for the CC aligned. Okay, yes, that's indeed the case. So that means I'm gonna just manually change it this time. CC aligned. I think it was Croatian. How did that even happen? I probably did not. Okay, because I manually had to do stuff there. So this is gonna be English Latin, and this is gonna be Croatian. Latin script. Okay. Found 8 languages. Five language directions. So we have, yeah, 2 for Serbian, 2 for Bosnian, 1 for Croatian. So let's see what we have. For Serbian, if we ditch Latin, we ditch most of the data because we have 300 million, actually sorry, 30 million in Cyrillic, and we have 74 million in Latin. For Bosnian, if we ditch Cyrillic, that's completely fine because it's either way super small. And then for Croatian doesn't have Cyrillic. Okay, for Serbian, ditching Latin will not be a good thing. But I currently don't have the option to use Serbian Latin because that language token is not supported inside of SPM 200. Okay, as the first order approximation, I just want to have everything running end to end with HBS and see what we get. I'm gonna just ignore the Serbian Latin. Okay. Let's go back here. Let's rerun populate data config. Data config directory, this is good. Exclude, we don't care about that. Data type train primary, all of this makes sense. Let's go to main. If it's train primary, then we do what? Then we save it to this YAML file, we write, and we call get primary data sets. Otherwise, we save to mind, and we call get mind. What's gonna be the difference here? Nothing really, other than the glob is a bit different pattern. And same for PT. Let's see, populate data config. Here it is. So we just need to specify the right root of our data. For us, that's the HBS data here. Copy that path and paste it right inside here. And after that, we can kick off the script. Here it is. Let's kick it off. Oops. Wrong argument. Wait, how? Populate data config. Populate data config. What happened? Do we have any required? Required is all set to false. Did I mess something up here? I don't think I have. Maybe just remove the comma here. Okay, kick it off again. Will it fail again? Yes, it does. Unrecognized argument, primary train paths. Why is that unrecognized? Aha. Primary train route. Rerun. Nice. And go here. Grab the corpus name. We have 5 different, here we have directions here. Source and target. Bosnian as the target, English as the source. Okay, this should work. Run. Data sets. Here it is. We have 5 directions. And for each of the 5 directions, we have a ton of different data sets. Especially for Croatian. Just see how it looks like now. I deleted it already. Okay. Run. And here it is. Five directions. In the train primary. Let's now see this one. Let's run it. So we're gonna grab the train primary. We open it up, we load it. Okay, let's just run this one. Prepare extra config. I think that's the one. Filter data root path, train primary config path. That's not the one that we want to use here. I think just no arguments should work here. Run. Okay, let's see what we get as a result. Included corpora, 95 datasets in total. Directions, Croatian the most, and then okay. Fair enough. This all looks good, except that we don't want to use all of this data. Where can I set that? YouTube is being used, that's cool. LID and toxicity, we need to set those. We need to modify this. All of that is good. I don't have to change that as well. Include the corpora, that's good as well. Okay, so we can kick this off. I just need to modify one thing, and that's directions YAML. If we just delete Serbian Latin here and Bosnian Cyrillic, will that be enough? Let's see. Run the filtering. Config, let me see whether I have to specify anything special there. So for filtering, only the output needs to be specified. So let's do filtered out and then HBS. Okay. Set the filtering, kick it off. We grab the directions. We have 3 directions. Corpora. And then, because we're running this locally, we'll be running this in batches. Directions, output directory, make this directory, and then just call this and then call the filter group. That's it. This is gonna now just run in the background. Let me just see. Do we have the right argument set here? CPUs per task 16. Memory in gigabytes. I don't think this is obeyed. This is not working for some reason. Let's see why. Why is it complaining? Because in the config I set some of these to none and it's failing for some reason. Did they do any changes here in this file? Just a second, guys. I have to see some private message. Let's navigate to this file. Did they modify it? No, I did not. Okay. So then why is it failing? We should be now doing simply processing these three language directions. Length factors is for some reason not computed. Okay, I remember why, because we were doing this. Backtracking some of the changes that we don't need anymore. This was computing the number of tokens, average number of tokens per sentence per language. Nice. Okay, kick this off. And we should have the length factors now. Okay, looking good. Rerun the filtering. Data sets, group name, train primary. Okay, we have 5 of them here. For if direction is not in directions, we ignore it. Okay, so this is acting as a filter. And then we call filter direction. Okay, so far so good. Yeah, this looks good now. Okay, we can actually kick this off now. And this, and the third direction, and that's it. So now in the background, what's going on is that we are doing we're applying 3 types of filters to our data. Those being length, deduplication, and the third one was what? Or is it just 2 maybe? Deduplication, length, and that's it. We are still to include LID, toxicity, okay. Nice. Well, this is running in the background. This will take a while, by the way. Maybe we can see how quickly it's progressing. It would be cool if we had like a progress bar. So I can maybe include just a TQDM or something. Let me think for a second. Okay. Yeah, if we put TQDM in here, will that yield us some progress bar? Let me see. Why not just put TQDM here? And then stop the run. Okay. Let's see whether this is gonna give us some progress bars. Huh, not really, because these are in, I guess, sub-process, and TQDM doesn't seem to work there. That sucks. Would be super cool if we could see the progress. I mean, we can always do something like this, and then 145,000 so far, whereas we have millions and millions. So okay, let's just remove this. Rerun. And we can just have this running in the background. So the amount of data we have is, we can easily see that here, 99 million for Croatian, 95 for Bosnian, and 30 million for Serbian, because we filtered out a ton of data that's in Latin script. Okay, while that is running, let me see what these are doing, these normalizations. When we're going through the lines, we have these two flags, normalized punctuation and Unicode. I think normalized punctuation for us is set to true. Let's just double check that's the case. So normalized punctuation set to true. And Unicode is not set to true. Why? Filter config. Normalized punctuation set to true, Unicode set to false. Why is that the case? So punctuation calls to replace Unicode punctuation. We just grabs the, goes through the text character by character, and basically does this replacement of Unicode with just regular. Okay, this makes sense. This is definitely something we want to have. That's the normalized punctuation again. So normalized punctuation. What about normalized Unicode? If we call normalized Unicode, then what we do is we call this Unicode data NFKC. I'm not sure what does the paper, how does paper handle this? Let's see. By the way, if you like, if I'm looking like I'm lower energy, that's because I am, because of jet lag. I'm still trying to just recover. Okay, normalize Unicode. What's the mention of Unicode? Normalize encoding to UTF-8. Okay, there is no mention whatsoever in the NLLB paper. I don't think this is gonna be important for HBS, but it will be important later. Okay. Let's see how we are progressing here. Okay, almost 1 million. This will take a while, guys, to process. While that's going on, I want to add additional filtering. So one of them is, I noticed we always have these quotation marks at the end and beginning of the sentence. We probably want to strip that. And we also want to add fuzzy deduplication and toxicity filtering. Those two should be fairly easy to add. And then LIT filtering as well. But again, the issue is we probably have to get some heuristics because LIT is not that good for HBS languages. And length ratio as well. Currently set to 9. Okay, the length ratio definitely needs to be changed. Okay, there's going to be a ton of work here. Let's just see how quickly this filtering state will be. How quickly can we iterate on my local machine? And then I'm going to add a couple of these additional filtering methods. Okay, guys, that's it for this stream. A bit shorter first day after the travel, so I also hurt my shoulder, so I have to go quickly to the hospital and just see what's going on. I think I have like a rotator cuff tendonitis or something. Managed to mess it up before I went to China, and it's still like causing me pain, so I have to check what's going on there. Catch you later. I'm gonna do a small break. As I said, I'm gonna check my shoulder, and then afterwards we have one more stream we'll continue working on the filtering method here, as I said. So keep an eye out for the open NLLB channel. That's where I'll be announcing all of the streams and everything related to the project. So guys, catch you later. Again, sorry if I'm a bit low energy. I'm kind of tired because of the jet lag. It will take a couple of days hopefully to recover, and then we can get back to the old pace. Cheers guys, catch you later. Hope you're doing well.